Welcome to the Teja Statistics. Today we are learning about ANOVA two-way classification. Let us consider a random variable y consisting of capital N observations. It is denoted by yij, where I runs from 1 to k and j runs from 1 to n. Each observation that is divided according to the two factors, that is treatments and blocks. Let us suppose that n observations are divided into k observations due to treatments. So n number of classes due to blocks, such that capital N is equals to n into k. Here you can see capital N is equals to n into k. The values of the variable y can be explained in the following table, two-way ANOVA classification table. This is treatments and blocks. So blocks are from 1 to j to n, and treatments I 1 to I and k. So y11, y12, y1j and so on y1n. So row wise total t1 dot and mean y bar of 1 dot. Coming to the column wise, that is block wise, totals are t dot 1 and means y bar of dot 1. So grand total, the total of total is grand total, and overall mean y bar of dot dot. Okay. Sources of variations also we have. Effect due to ith treatment alpha I, effect due to jth block, that is beta j, error effect due to chance, which follows normal distribution. Next we can see the mathematical model. In two-way ANOVA classification, the linear mathematical model will be yij is equals to mu plus alpha I plus beta j plus epsilon ij, where yij is the yield. Okay, yij is the yield from the jth block by applying ith treatment. So these are all general mean effect and their formulas you can see. So new formulas, that is next term. Alpha I is the effect due to the ith treatment. Alpha I is equals to mu I dot minus mu. So here you can have the formula also. Next beta j. Beta j is the effect due to the jth block. Next we have to note summation I runs from 1 to k. Alpha I will become 0. Summation j runs from 1 to n. Beta j will become 0. Next assumptions for this ANOVA two-way classification. All the observations are independent. The various effects are additive in nature, and epsilon ij follows IID. Identically independent. Okay, identically independent. So IID follows normal distribution with 0 comma sigma square. Null hypothesis. We have to set up the null hypothesis for the treatments and blocks separately, as their effects are homogeneous. For treatments we are writing HT alpha 1 is equals to alpha 2 is equals to alpha 3 and so on, alpha k equals to 0. For blocks, all the block effects, okay, that is beta 1, beta 2, beta 3 and so on, beta k equals to 0. The parameters mu, alpha I, beta j are estimated by the principle of least squares for minimizing the error of squares, error sum of squares. So we are using the principle of least squares from the model. So error estimate we are estimating. So we had to apply the principle of least squares. The sum of the squares of the deviation is minimum. So here we are writing the E value, it is double summation yij mu minus alpha I and beta j square. Differentiating with respect to the mu and equating to 0, then you will get. So here the power will come down, the 2 will come down here, and double summation, and here we are partial differentiating with respect to mu, then we are getting minus 1 extra. So double summation will remain same, and all double summation if you apply, then the 2 and minus 2 will go 0, and double summation to the whole bracket if you apply, then you will get alpha and beta z values as zeros, since we already studied about the note. Okay, so double summation of yij is equals to double summation of mu. So if you remove the summations, you can write n into k, so which is our the value of capital N. So, double summation of yij divided by n into k is equals to mu. This is the formula of means of mean, that is overall mean y bar double dot. So you got equation number 2. Next you can have differentiating with respect to the alpha I and equating to 0, the same integration will come. So here we are giving one clue to easy and simple derivations. So if you are differentiating with respect to the alpha I, just consider the summation j values. Okay, so summation j values if you apply, then you will get the answer like this. Okay, so you are going to get alpha value 1 by n of summation yij, okay, of is equals to mu plus alpha I. So from that you can write that is y bar of I dot minus y bar of dot dot equals to alpha. This is the equation number 3. Again you have to differentiate with respect to the beta j. So and equating to 0, again we are applying the simple technique. If we are differentiating with respect to the beta j, then you can apply the summations here of alpha I, that is I runs from 1 to k, you can apply. Okay, you can apply the summation I values over here. Okay, k into mu plus beta j is equals to double summation of summation of I runs from 1 to k, then you will get the beta j value from here. So what is our beta j? Here y bar of dot j, that is here they did not wrote y bar of dot j is equal minus y bar of dot dot is equals to beta j. So consider the mathematical model and substitute all the values for getting the epsilon ij value. Epsilon ij value you got yij minus y bar of I dot minus y bar of dot j plus y bar of double dot. Put it as equation number 5. Substitute all 2, 3, 4, 5 in equation 1. Then you will get the model. Yeah, now taking this overall value, this is the mu value, this is the alpha value, this is the beta j value, this is the error value. So if you just move this value y bar of dot dot to the left hand side, then it will become our model. Now summing over I and j and squaring on both sides, then we will get the formulas. Okay, these are the formulas, and which is our model is n we are applying for alpha treatment, so k is applying for uh, beta j treatment, then error square values. Okay, so total sum of squares TSS is equals to SST plus SSB plus SSE. So you can write the degrees of freedom also. The total sum of squares of n minus 1 degrees of freedom, the sum of squares of treatments k minus 1 degrees of freedom. Next, sum of squares of due to blocks n minus 1 degrees of freedom, the sum of squares of errors. If you write the degrees of freedom n minus 1 and minus of k minus 1 minus of n minus 1, if you simplify that one, you will get the degrees of freedom like n minus 1 into k minus 1. Next, we are writing the mean sum of squares. So the mean sum of squares for the treatments is SST divided by k minus 1. That implies ST square. Just we are denoting with that. Next, mean sum of squares for the blocks SSB whole divided by n minus 1 SB square. Next, mean sum of squares for the errors SSE whole divided by n minus 1 into k minus 1, then you will get SE square. Yeah, test statistic we are applying. So chi-square test we are going to use here. These are the chi-square variates. So formulate the that is for treatments. F calculated for treatments is ST square divided by SE square. For blocks, SB square divided by SE square. So conclusion, if all the calculated values are of treatments and blocks are less than or equals to, then we are going to accept. If it is greater than or equals to, then we are going to reject the null hypothesis. What is our null hypothesis? That which we already discussed. Okay, the final ANOVA table for two-way classification. Please look at how many number of sources of variations are there. Treatments, blocks, errors. Treatments, blocks, errors and totals also. So this is an application of ANOVA two-way classification, and the sum of squares and degrees of freedoms and mean sum of squares also, and F calculated values also. So up to this you have to explain all ANOVA two-way classification. Please learn each and every calculation carefully. We are just estimating by using the error estimate, and also what we are doing, we are applying the principle of least squares, and the definitions also and notations also we are using carefully. Okay, from here onwards, if they ask in your examination, you have to start with ANOVA two-way classification from here and up to end with what? ANOVA table. ANOVA table. Just see, up to this you have to write. Okay, thank you.
அண்ணன் யாரு